basic idea behind the Monte Carlo simulation is to randomly generate values for the unknown variables in the models. So look at this now. Look at this question. Quest World is a first-class retail chain that has a store in the New Kingston area. Quest's main product is its high-end phones, among which is the Torch. Quest orders 15 Torch from its supplier when their inventory reaches 5 units. What do you think the 15 represents?
EOQ.
Reorder quantity.
Reorder quantity.
Reorder point.
Reorder point.
Q star.
Q star.
Thank you.
Yeah.
Not the reorder point, guys. 15 is the economic order quantity.
Okay. Oh, yes, yes.
5 is the reorder point.
The point.
Yes, yes.
Okay, guys? The company orders 15 torches from their supplier when their inventory reaches 5 units. The reorder point is 5.
5, yes.
But the 15 is their Q star figure. Does that make sense, guys? Based on what you've been
Yes.
learning?
Sir.
Yes.
Yes, sir.
Everybody?
Yeah.
Does that make
Yes.
sense? Daily demand for torch varies according to the probability distribution shown below. There is no lead time since orders are received the next day in time for sale. The cost to hold 1 unit in inventory for 1 day is 50 cents. The cost to place an order to replenish their inventory is $100. Stockout costs are $40 and the initial inventory is 15 units. That's like the opening inventory. Here's the probability distribution function that we are given. We are asked to calculate. So let us understand the probability distribution function here, which in practice you would get this from historical data. You'd have to look at the company's historical records and see what the data suggests. For example, the probability that the company will sell 0 products on a given day is 5%. The probability that they will send 1 unit on a given day is 5%. The probability that they'll sell 2 units on a given day is 20%. The probability that they'll sell 3 units on a given day is 30%. The probability that they'll sell 4 units on a given day is also 30%. And the probability that they'll sell 5 units on a given day is what? 10%. Do you follow me? Are you with me there, guys?
So far.
This information would obviously come from historical data, right? Make sense?
Yes, sir.
Yes, sir.
So you would have to look at historical data and say, okay, from all the sales information we have, sales of 2 phones were recorded 20% of the time. Sales of 4 phones were recorded what? On a given day, were recorded 30% of the
30%.
times, and so on. You get the drift?
Yes, sir.
So that would have to come from historical data. Now we're asked, calculate the company's expected daily demand. So to calculate the expected daily demand, what we will do, this is a very important guiding question. This question here is a really important question, okay? So the expected daily demand is found by multiplying the daily demand by the corresponding probability, like how we find the expected monetary value. So it says 0 multiplied by what? Probability of
0.05.
0.05
plus close bracket
plus 1 multiplied by the probability of 0.05
plus
plus
2
2 multiplied by the
And
probability of 0.20.
plus.
You with me, guys?
Yes, sir.
Good. Plus what? 3
3
multiplied by the
divided
probability of 0.30
0.30 plus 4
plus 4 multiplied by the probability of what?
0.30
0.30 plus
plus 5
5 multiplied by the
times
probability of
0.10.
0.10. Tell me if you get it.
Yeah.
Let's work it out now. Equal 0 multiplied by 0.05 is 0. 1 multiplied by 0.05 is 0.05. That's how we find the expected value, by just multiplying each observation, in this case daily demand, by the corresponding probability, guys. Does that make sense?
Okay.
Then, everybody's seen how we came up with these inputs here?
Yes.
E of
Yes,
x here means
Yes, sir.
expected value, by the way. E of x means expected value, okay?
okay.
The notation E of x means expected value. Now, 2 multiplied by 0.20 is what? 0.40?
Yes, sir.
3 multiplied by
0.90.
3 multiplied by 0.30 is what?
0.90.
0.90. 4 multiplied by 0.30 is what? 1.20.
Shall I bring up your screen? Right.
5 multiplied by 0.1 is what?
0.5.
0.5.
Put in your plus sign, sir.
Mm-hmm. Are you with me, everybody?
Yes, sir.
And then we're going to simplify this now. When we simplify this, we're going to get equal 0. Well, let's add them. When we add up all of these, what do we get?
3.05.
3.05. Or approximately what?
3.
3
3.
units per day. Everybody's understand how we did this calculation?
And that is what your average, sir.
Yeah, that's like your average, exactly. It's your average daily demand. That's exactly right. It's like saying that is your average daily demand.
What is say must
Okay,
calculate
the
the
summation, sir.
expected daily
The average
demand.
daily demand for phones, kind of
Sir.
phone, touch phones, is 3 phones per day. That's what this is saying. And to calculate it, we multiply the daily demand that we have documented from historical data by the corresponding probabilities and add up the results, what we have here.
So,
Yeah?
sir, isn't that the summation of expected daily demands rather than average?
Yeah, that's what I'm
The,
saying.
so the expected value is called the average.
Okay.
Oh,
Just another term for it.
Excuse me, sir. Could you just scroll back to the question, please? Thank you.
All right, everybody is good?
Yes, sir.
All right. So everybody is clear on how we got that expected value, right? Now the question says we should construct a random number mapping for the random variable. The random variable here being daily demand. So what I do is that I take the original table. The original table only has 2 columns, right? Which are what? The daily demand and the probability of those daily demand, right, guys? I take that information, create a new table with daily demand probability, and I'm going to add a column called cumulative probability. So this is to answer the question of construct the random number mapping for the variable. So we're going to construct what is called a random number mapping intervals for the table. Not the word intervals. Construct the random number mapping intervals for the random variable being daily demand. Okay? So we take the same original table that we were given, which just had daily demand and probability, and I add an extra column called cumulative probability. I'll tell you about these other 2 columns shortly. But for my extra column called cumulative probability, let me make sure you understand where we are here. We're at B, where we're asked to do what? Construct the appropriate random number mapping interval for the random variable. Are you with me, guys? To do this, we're going to add, the first thing we're going to do is to add an extra column to the table and call that column cumulative probability. Got it? Now, how are we going to find this cumulative probability? So this is to answer the question now of constructing random number mapping intervals. So we're going to say here 0.05, start with the first probability, and then keep adding the subsequent probability until we reach the final figure. This will now be 0.05 plus, which is the 0.05 brought forward from the first cell, plus 0.05 equal 0.10. Are you following? Then I bring forward that 0.10.
Sir, do that again. Sorry.
I start out with the first probability. The first probability is also my first cumulative probability. 0.05, 0.05. Okay? Remember, this is the original information we're given, and we add a column called cumulative probability, okay? Now we start out, the first cumulative probability figure is the same as the probability figure of 0.05. Then I bring forward this 0.05 that I'm circling and add the 0.05 that I'm in line with to that figure brought forward, which is 0.05. So I get 0.1. Got it? Then I bring forward that 0.1 and add the probability that I'm in line with, which is 0.20. And I will get 0.30. Tell me if you get it.
Got it.
Then
Yes, sir.
bring forward that 0.30 from the cell before, the cumulative probability cell before, and add it to the probability that I'm in line with, which is 0.30, and that gives me 0.60. Get it?
Yes, sir.
Body's okay?
Yes, sir.
Yes,
Then
sir.
all right, then we bring forward this 0.60 plus 0.30. 0.30 that I'm in line with, probability I'm in line with, which is 0.90. Then what will I do with that 0.90? Bring it forward.
Add it to
then you get
0.10.
Very good. Excellent. And
Equal
add it to the
1.
probability of 0.1 that I'm in line with, which is 1. Cumulative probability must end with 1. Must end with 1. If your cumulative probability does not end with 1, something is wrong. So it starts with the first probability figure and end with 1. Always and everywhere.
So it's basically the sum of the probabilities.
It's the sum of the probabilities, exactly. Total probability must add to 1. Well done.
Are the same as 100%.
It is the same as 100%, the whole. You get it, guys?
Yes, sir.
All right. Now, after you've added that cumulative probability column, you then add a column called random number intervals, because this is really what we're trying to come up with. The random number intervals. So 2 columns are added to the original table. The cumulative probability column, because remember the original table is this, demand and probability. To that table, just add an extra column called cumulative probability and compute the cumulative probabilities as we did here. Then add another column, a second column called random numbers, random number intervals. You're going to see how it becomes important soon. Random number intervals start with 0. You say 0, 2. This hyphen means 2. Okay? The hyphen means what? 2. 0, 2. 1 unit less than the cumulative probability that I'm in line with. So the random number intervals start with 0. We're finding an interval. Interval is like 5 to 9, 10 to 15, 20 to 25. Intervals. We're coming up with the random number. Intervals. So this is 0. We started with 0, 2. Follow me. To 1 digit less than the cumulative probability that I'm in line with.
So 0.04.
Which is 0.04. 0.04. Excellent. So it's 0 to 1 digit less than the cumulative probability that I'm in line with. Everybody see?
Did you do that for all of them?
No. Just follow me. Just follow me on this. Follow me on this. Just make sure you get this. Once you get this, we'll move forward. So always start with 0 to 1 digit less than the cumulative probability you're in line with to start out. Let me know you're clear on this. Everyone is clear on that first interval in the random number interval?
Yes, sir.
Okay.
All right.
All right, sir.
Mm-hmm.
So, mathematical principle. Here, you're saying where the random number intervals, and we're applying it. The dash or the minus sign in this case would represent 2.
2.
That would be the English version of what that means.
Yes, correct.
But is it that we have to use that particular sign, or can
You
we
use 2 if you
literally
want.
write
You can
TO?
spell out the word 2 if you want.
That's how we want to know.
Yeah, man.
All
You
right.
can spell out the word 2 if you want to spell out 2. 0, 2,
Right.
0.04. That is fine.
Just want to make the distinction.
Yeah, man. No problem.
But me understand say
Why
the
is that
maths of it in English is
5.04 again, sir?
1 unit less than the cumulative probability you're in line with.
Okay, sir.
Cumulative probability we're in line with is 0.05, so you go 1 unit less. All right, I want you to pick up the pattern. Look at the pattern now. After the 0.04, which is the upper limit, you have a lower limit here of 0 and an upper limit of 0.04, right? Keep counting and say after 0.04, what comes next?
0.05.
0.05.
to 0.09.
So we go to 0.05, follow me. Go to 0.05. Just keep counting. After the upper limit, just keep
To
counting.
0.09.
To 0.09.
Good. To 1 unit less than the cumulative probability we're in line with.
Okay.
The probability we're in line with is 0.10.
Mm-hmm.
1 unit less than it would be 0.09. Tell me if you
Yes,
understand that
sir.
second
I
interval.
got
Once you
it.
understand that second interval, the rest of it is history.
History.
So, sir, question.
Mhm.
Can it be said then that for the next interval that you're in line, it becomes the lower limit automatically?
Absolutely.
Cool.
That is it. Brilliant observation.
Sir,
So, yeah,
sir, can I get a go at the third one?
of course, Shauna, go ahead.
So that would be
point
Point
zero
one
six,
zero.
Point what?
0.06.
Well,
No.
remember, you're going to be counting from the upper limit, not
From
the
the
lower one.
last one,
Zero
okay.
Right,
point
you're
one.
counting from the last
.01.
one to get the
0.10.
0.10, Shauna, exactly.
Yes.
Because
Two
0.10 is 1 unit up from the upper limit before, which is 0.09,
Right.
right? To what?
2.29.
0.29, exactly. Brilliant. To 1 unit less than the cumulative probability you're in line with. Well done. Guys, look at it carefully and make sure you get this. This is crucial. Take a couple seconds, look at it, make sure you're assimilating what's going on.
Is that spelled out in the notes, sir? Like when I get the printout, is that spelled out in the notes?
It's spelled
Okay.
out, but maybe not as simple as we're talking about it right now, you know?
Oh.
Yeah.
Sir, can you go over it for me, please?
You mean from the top?
Yes.
Word. All right. So you're clear. You're clear on the cumulative probability, right? Person who asked the question.
Yes, I am.
So the random number intervals start with 0. We're constructing the random number interval now. So you say 0 to 1 unit less than the cumulative probability we're in line with. Guys, community rules, thank you. So it'll be 0 to, you tell me, what is 1 unit less than the cumulative probability that we're in line with?
0.4.
0.04. Two decimal places, right? Then you have an upper limit here of 0.04.
Emily and mute.
Yeah.
And is it that we always start at 0?
Guys, just remember the community rules, all right? Okay. So 0 to 0.04, then what?
Dr. Dennis, I have a question. Is it that we always start at 0?
Yeah, remember we said that always start at 0. Always start the random number intervals at 0.
Okay.
Always. 2, 1 digit less than the first cumulative probability figure. That's always how you start out. 0 to 1 digit less than the first cumulative probability figure, which is 0.05. 1 unit less than that would be 0.04. You get it? Then, essentially, you're going to pick up 1 unit above the upper limit. What is the upper limit in the first interval here? Is a lower limit of 0
0.04.
and an upper limit of 0.04. So you pick up at 0.04 in the next cell. 2, 1 unit less than the cumulative probability you're in line with. So the upper limit is always going to be 1 unit less than the cumulative probability you're in line with.
Sir, that is
So
not
the
what you
next
said
line should
first.
start with 0.05.
0.05, sir.
Yes.
5.
Yes, 0.05.
That's
Yes.
correct.
1 unit more than 0.04 gives us 0.05. 2, 1 unit less than the cumulative probability that we're in.
Yes.
Are you following? Person who asked the question, I didn't pick up the name. Are you following?
Yes, sir, I'm following you.
Then you keep counting from the upper limit of 0.09. You move 1 unit up. This is the upper limit of 0.09. You use move 1 unit up to 0.10. 2, 1 unit less than the cumulative probability that we're in line with of 0.30. So that's going to be 0.29. Get it? Everyone is good there?
Yes, sir.
Okay. Kadia, do you follow that?
Yes, sir, follow.
All right. Now, what is the upper limit in this interval?
0.2.
0.30.
0.29. 0.29 is the upper limit.
9.
Yes.
So you're going to add 1 unit to that upper limit. to give us what?
0.30.
0.30.
That's right. 2
2.59.
to 0.59,
0.59.
which is 1 unit less than the
Cumulative probability.
cumulative probability. Excellent. That we're in line with. Tell me if you follow it. Look at it and make sure you get it.
So you must leave it there, you know, so I will remember what was done to arrive at the result.
Definitely.
Yeah, so don't worry about none of that.
No, man, not at all.
Sir, I'm seeing a pattern.
There is a pattern. There are
I
some
see.
formal and informal patterns. You can, whatever works for you, really, as long as it's ironclad.
No. I'm just looking at the first numbers in the cumulative probability.
Will
The
always
same,
be
the same number in the first set of
the lower
numbers.
interval, lower limit.
The
Yeah.
lower limits, yes.
Yeah, but you know, some people might do the
Sir,
cumulative
1 minute,
probability.
sir.
Some people might do the cumulative probability without showing the addition, which is actually okay if you can do it mentally. Or
Sir, don't want to jump the gun, but the last number in the cumulative property is the first number in the next random interval.
yeah, that's what Jackie is saying, but that is provided that you show your calculations, which is why I don't want to generalize that. Provided that you show your calculation here. Some people might not. Some people might just do their additions to form their cumulative probability without showing the workings here, which is actually okay. It's acceptable.
Sir,
Go
I'm
ahead.
curious to know what the last one is gonna be.
Right. Well, this one that we're in right now is going to be what? 0.60
0.60
to
1 unit up from 0.59, right?
0.89.
2.89.
2.89, which is 1 unit less than the cumulative probability that we're in line with.
Then you have 0.9
Good.
to 0.99.
0.90, which is 1 unit up from the upper limit of 0.89.
To 0.99.
0.99, which is 1 unit less than the cumulative probability of 1. Got it?
Yes, got it. Yeah.
Yes,
If
sir.
you get it, guys.
Yeah, man. Sir, I have a theory. Just want to confirm. Basically, the summation of all the random probabilities must lead back to 1 because the cumulative probability must go back to the end result of 1, right?
Yes.
So it is also theoretical that the final interval that you will have will always be 0.99.
That is right.
Cool.
Very good. Excellent. Excellent mathematical inference. Everyone is fine with this? Anything you want me to reinforce, go over, simplify, whatever, just let me know. If you're all good, we move on to the next column, which is alternative. Any questions? All right, so the
All clear, sir.
You good?
Yes, sir. All clear.
All right. The alternative random number mapping column is where I'm going to go now. You don't have to do this third column. It's not necessary, but I'm showing you for ease of reading. Alternative random number mapping. This one you don't have to add. It's really simple. As long as you can read this column that I'm highlighting well, then you don't need this last one. So I label it alternative random number mapping, which is just to convert these numbers to whole numbers, 0 to 4. Then what? 5 to 9, just to express them as whole numbers. because we will need to read the probabilities as whole numbers. 10 to 29.
30 to 59.
30 to 59. Everybody is good?
Yes, sir. But
Yes,
what is
sir.
the reason though?
All right, just hold on a bit. You'll see the reason because we're going to need to read the probabilities as whole numbers.
I'm not decimal.
You'll see that in a few minutes. So if you are
Okay.
okay with just reading, if you are okay with reading the probabilities as whole numbers without doing this conversion, then you don't need this column.
You mean as decimal, sir?
We're going to have to read these decimal probabilities as whole numbers. So if you're
Okay.
able to recognize them if you're able to recognize the whole numbers associated with them, then you don't need
Yeah.
this extra column.
Okay.
Yeah. Everybody is seeing how we get this last column? So we just convert each of these random numbers to whole numbers. 0 to 4, 5 to 9, 10 to 29, so on. Tell me if everyone is clear out there.
Yes, sir.
All right, so remember now what we were just asked to do was to construct the appropriate random number mapping intervals. That's what we were asked to do, and that's what we have done. All we did was to take the original table, which had demand and probability, and add this extra column, cumulative probability, then generate the random number intervals from the cumulative probability and the alternative final column, which is just expressing the random number intervals in whole numbers. Tell me if everyone is good with this. Is everybody okay? Anything you want me to reinforce? That's a really important question, okay?
I'm okay.
All right, good. All right, I'm just going to do a little thing here to help you. So we could say this is, I'm going to put these numbers in red, red, red. And the keys, those were the values that we brought forward. See the key there? Value brought forward. And this as well, red. Value that was brought forward and added to the probability that we are in line with. Okay, guys, are we okay? All right, so I'm going to move on to the next one then. C says, simulate 8 days of demand. In other words, we're going to predict 8 days of demand for this company's product by using the random numbers given. It says simulate. In other words, predict 8 days of demand by using the random numbers given. Predict 8 days of demand by using the random numbers given. Now, I want you to look at this table very carefully, guys. Random numbers to be used in simulation. Day 1, 0.57. Day 2, 0.59. So this table will be given to us, right? In an exam situation. But in reality, how do you think you would get these random numbers for demand? You could go to what?
Equal to rand.
Excel sheet.
Go to
Go to
Excel.
Excel, say equal rand, open bracket, close bracket, enter. And like your first random number here, if you want 2-digit random numbers, would be what?
1.19, 0.19.
Or 20 roughly, right?
0.2.
Yeah, 0.2 or, yeah, exactly. Or 20. And the next one would be what?
0.5.
4.
0.05.
Or 5, yes. Then what?
0.18.
And so on. I'm showing you that in reality, in real life, the random numbers would come from using the rand function in Excel. So this is where we would have gotten these from to punch into this question for 8 days.
So question, sir.
Yes.
What if you just randomly select some number yourself rather than putting it through Excel? Will that work as well?
I guess it can. Technically speaking, it can.
Okay.
Yeah, technically speaking, it can. Yes,
Sure.
technically.
Can
But we
you
want to make it as scientific as possible, you know?
No problem.
Yeah.
Yeah, but how you maneuver something like this in the exam when we're not doing Excel?
You would be given the random numbers, like how you're given it here.
Right.
Mm-hmm. Instead of you having to come up with the random numbers from Excel, you're given it. Just like this table. This table gives you the random numbers to use for each of the 8 days of demand that you want to predict. So I'm going to show you how this works now. Follow me keenly, all right? Look at this table and make sure you understand what's going on in this table first and what this question is really asking. It says simulate, which means that we are really asked to predict 8 days of demand. You with me?
Sorry, you're muted.
Not hearing anything, sir.
Oh, I'm sorry. All right, so that's how that works. You get what I'm saying here? So basically, how many days are we asked to predict the demand for? Simulate 8 days of demand means that we're going to predict 8 days of demand using these random numbers. So this is day 1, day 2, day 3, day 4, day 5, day 6, day 7, day 8. And for each of those days, we have an assigned what? Random number. All right. That's what the question says. And you're given this table to complete. All right. This is the table. I'm going to clean up this table. I'm going to take out all the numbers from this table. All right. So I'm going to take out all of these. Typically, you're given a question like this in the final exam. Okay, guys? Just telling you.
Your question, them waiting every still, you know, sir.
Waiting?
Yeah, man. You have a lot of work to just get 2 marks.
You mean like in the mid-module?
Yes, sir.
Oh.
Definitely, sir.
All right. Well, it's good practice. All right. So follow me keenly now. Everybody is okay so far, right? Okay. Now, you're given this table to fill out. You're given this question, simulate 8 days of demand by using the random numbers given. And you're given this table to complete as well. To complete for the solution, okay? So, here we go. Follow me, guys. Here we go. Day 1. So look at the table. Day 1 and the daily demand. We're going to come up with day 1 and the daily demand first. What are we going to come up with first in this table? Day 1 and the daily demand. Because obviously we need that information to do anything else in the table, to calculate holding cost and so on, right? We need the demand. So for day 1, here's what we do. Follow me keenly now. For day 1, you will go to the random number table and say, what is the random number for day 1? What is it, guys?
0.57.
0.57 is the random number for day 1.
Right.
So you copy and paste the numbers them from day 1 to 8 back into the table.
No. Look what is going to happen. The random number for day 1 is 0.57 or 57 because demand would be in whole numbers, right? Go up to the random number table that we created and say, where would 57 fall in the random number intervals? Where would it fall?
3.
Good. It would fall between 30 and 59. Therefore, the predicted demand for day 1 is 3. And you put 3 here. Daily demand 3.
Okay.
You get it?
So basically, both tables now work in tandem for you can get to fill that out.
That is it. So the tables are all working in synergy now.
Okay, sir.
See? So for day one, we say, okay, day one, what is the random number? 0.57. Bam. Go up to 0.5, go up to the table and say, where would 0.57 fall? Between what? 3?
That's it.
Between
So that
30
is
and
3 units
59,
for that
right?
day. Yes.
Mm-hmm. And then you put that 3 right there. Then you go to day 2.
Day 2 is
Go
3
back to the
units
random
again.
number table and say, what is the random number for day 2?
3 units again.
59 is the random number, or 0.59, right? Then you go
Yes.
back up to the random number table, interval table, and say, where
Reach
will
out at 3
0.59
units.
fall between these two figures of 0.3 to 0.59, and the daily demand is also 3. Fill in that 3. The only reason, the only use that we're making of the random number tables working in synergy here, this one and the one we came up with, is to fill out the daily demand column. You're predicting that the daily demand on day 1 of operation is going to be 3. Then day 2 would be 3 as well. Then we go to day 3 and we say, what is the random number for day 3 that we're given?
4 units.
Hold on, Karen. Just hold on a little for me, Karen. Let's get some more students involved, all right? Thank you. Appreciate it. So on day 3, the random number is what, guys?
0.84.
0.84. What do you now do?
You
Go
go
up
to
to
the
what?
Go back to the table.
Back to your
Back to the
table.
random number intervals and say, where does 0.84 fall?
4.
At
At
4.
day 4.
Good. It falls between
4 units.
0.6 and 0.89, which is a
Right.
demand of 4
4.
units. You getting it, guys?
Yes, sir.
Yes.
Then you fill
Yes,
in the
sir.
4 right here on that at day 3. Then you go back up to the random number table, simulation table that we're given. And we're now at day what? 4, which has a random number of what? 0.19. So what do you do now? You want to find out what will be the demand, what will be the predicted or simulated demand for day 4.
Go back to the table.
You go back to your
up to the
table.
interval table and say, where will 0.9 fall? Between what?
Day 2.
It will fall, not day 2, demand 2.
Demand.
2.
Yeah, demand 2. It will fall between 0.11 and 0.29, which has a demand of what? 2.
2.
Yeah. And then you plug in that 2 right here for day 4. That's the predicted demand for day 4. So you can literally use this kind of model called the Monte Carlo simulation model to forecast demand or daily activity at your workplaces. See where I'm going with this, guys? Let's now go to day 5.
What?
You tell me, somebody volunteer. One person just volunteer to walk us through day 5. Somebody
Day
can volunteer
4.
to predict the demand for day 5.
Sorry, go back up to the
Right, so let's start, Shauna, by saying day 5 has a random number of?
Point of 82.
Day 5 has a random number of 82.
82.
So to search for this 82, we go back up to
Go
the
back to the
random number intervals and locate what?
The daily demand.
Mm-hmm.
The random number the random number, sir, that's between that will give you 82.
Good. We locate the interval that 82 would fall in.
Right,
Which
intervals
is
that where
between
82 would fall.
0.60 and 0.89. 82 would fall in that interval, right?
Right, sir.
Which corresponds to a daily demand of what, Shauna?
4.
Excellent. And what do we do with that 4? Go down to the table.
To the
and put
table
in 4 at day?
Day 5.
Good. Very good. Well done, Shauna. Are you with me, guys?
Yes, sir.
Sir.
All right. Can somebody else walk us through day 6? We're now at day 6. We want to predict the demand for day 6. So we go back up to the random numbers that were given to use. Can somebody walk us through day 6? So day 6 has a random number of, go ahead.
Of 90.
All right, Claudette. So day 6 has a random number of 90.
So we go up to the table.
Mm-hmm.
Random number intervals. We look where 0.9 falls.
Good.
And it falls at a daily demand of 5 units.
Brilliant. Then?
We go back down to the table.
Good.
And we add, it was 5 we said, sir? Yes, at day 6.
Yes, 5.
Well done. Brilliant. Very good, very good, very good. Is everybody okay out there?
Yes, sir.
Yes, sir. So far, so good.
Yes, sir.
Make sure everybody is fine. Then we go to day 7. So we want to now predict the demand for day 7. So we go up to the random numbers that we are given. And for day 7, the random number that we're given is 0.02, right?
Yes, sir.
Or 2. So what do we do? Go back up to the random number intervals and look for what? The interval that 2 falls in, right?
Where it falls, yes, sir.
Good, which is between 0 and 4 here, right?
Yes, sir.
Which has a daily demand of what?
0.
Brilliant. Brilliant. Guys, make sure if you're planning to do a simulation, you have to be able to manipulate this kind of question, all right? You normally get a question like this standing alone on simulation. Okay, everybody? Everybody's all right?
Yes,
Let's
sir.
now go to the final day, day 8. So we scroll back up to the random numbers that were given. On day 8, what is the random number for day 8?
0.11.
0.11, or we could say 11, right? Go up to the random number intervals and look for 11. Which interval will it fall in? Between 10 and what?
Sorry.
2.
Daily demand is 2.
0.29.
Good. Between 10 and 29, or 0.1 and 0.29, which has a daily demand of what? 2.
2.
So we insert the 2 here. And that's our prediction for the next 8 days. That's the Monte Carlo simulation. So to start out, we were asked to calculate the expected daily demand. The expected daily demand is 3. We did that by multiplying each of the daily demand figures in this table of historical information by the corresponding probabilities and sum the results. We got 3. Then we were asked to construct the appropriate random number mapping intervals. So we took that original table, this table that we were given, and we added an extra column called cumulative probability. We started out with the first probability of 0.05 here. Always start the cumulative probability with the first probability you're given, then bring it forward here in red and add it to the probability of 0.05 that you're in line with. We get 0.1. Then bring forward that 0.1 to the next cell right here in red and add it to the probability you're in line with of 0.20, and we get 0.30. Continue that process until you reach 1. The cumulative probability must end with 1 because total probability adds to 1. For the random number mapping intervals, we start with 0 at all times in the first cell, to 1 unit less than the cumulative probability we're in line with. So we get 0, 2. 1 unit less than 5 is 4. So with 0 to 0.04. Then since 0.04 is the upper limit here, we add 1 to it to move to the next cell to get 0.05. 2, which is what the dash means, 1 unit less than the cumulative probability that we're in line with. Cumulative probability we're in line with is 0.1. So 1 unit less than that would be 0.09. Then we keep counting and say, okay, since the upper limit here in the random number interval is 0.09. We add 1 to it to get 0.10. Add 1 unit to it to get 0.10. 2, 1 unit less than the cumulative probability that we're in line with of 0.30, so we get 0.29. Then again, we add 1 unit to the 0.29, which is the upper limit in the interval that we're at right now, to get 0.302, 1 unit less than the cumulative probability of 0.60 that we're in line with, which is 0.59.
Question, sir.
We continue that process until it ends. Sorry, 1 second. The last column here is optional. As you realize, it's just converting the random number intervals to whole number form if you prefer to read. It's easier for you to read as whole numbers, but it's not absolutely necessary. 1 second there, Howell. Then in C, we're asked to simulate 8 days of demand, which means predict 8 days of demand using the random numbers that we're given. So we're given random numbers for 8 days here. 0.59 for day 1, 0.57 for day 1, 0.59 for day 2, and so on. And we're also given this table to complete. So the first thing we did was to generate the daily demand column. First, generate the daily demand column. To do that before anything else in the table. So to generate the daily demand column, we went to the random numbers that were given for the respective days. So for example, for day 1, the random number for day 1 is 0.57. In practice, we would generate this from Excel, the random numbers, but in reality, you can generate them using the rand function in Excel. So we go to 0.57. We said, okay, for day 1, the random number we're simulating for is 0.57. So we go up to the random number interval table and say, where does 0.57 fall? It falls between 0.3 and 0.59. Therefore, the predicted demand for day 1 is 3. And on day 2, the random number that we're given is 0.59. So we go up to the random number intervals and say, where does 0.59 fall? Well, it falls between 0.3 and 0.59 in the random number intervals here. And so the predicted daily demand that corresponds with that is 3. So we slot in 3 here for daily demand. Continue that process until we've completed all 8 days. Are we good, guys?
Yes, sir.
All right. Howell, you had a